Hello and let me welcome you to the magical world of computer vision. Computer vision, it's an AI-based, that is artificial intelligence-based technology that allows computers to understand and label images. It's now used in convenience stores, driverless car testings, security access mechanisms, policing and investigations, surveillance, daily medical diagnosis, monitoring of health of crops and livestock, and so on and so forth, even to analyze data coming from outer space, stars, planets, etc. Also we use computer vision. A common example will be the face detection and unlocking mechanism that you use in your mobile phone. We use that daily. That is also a big application of computer vision. And today top technology companies like Amazon, Google, Microsoft, Facebook are investing millions and millions of dollars into computer vision based research and product development. So learning and mastering this fantastic world of computer vision based technology is surely upmarket, and it will make you proficient in competing with the swiftly changing image processing technology arena. And this course is designed in such a way that even the very beginner to programming can master the computer vision based technology. Here are the major topics that we are going to cover in this course. We will be mainly concentrating on OpenCV, which is the open source computer vision library. It's being used all around the world in providing computer vision based technology. So we will have an introduction to OpenCV, the features, the version, all the other details we will be discussing in the first session. In the second session, we will be installing a VirtualBox with Ubuntu 18, the latest version of Ubuntu Linux in it, so that we can have our computer vision based laboratory set up separately rather than we need to install all the packages and everything into your computer or laptop that you are using daily. So it's better to have a separate lab setup so that we can play and get our hands dirty with the computer vision based programs, examples, exercises and all. And in the third session we will be installing the libraries that are required for computer vision programming. We will be mainly using Python program. Python is actually the language which is mainly used for scientific, this kind of research purpose and all. So the best combination will be Python, OpenCV and Linux. The best ever combination to run our OpenCV based computer vision programs. And in the next session, we will set up our IDE, which is Sublime Text. We will install and configure the Sublime Text inside our Ubuntu virtual machine. In the next session, which is a theory session, we will have the concepts, the pixels, size, image, and all the concepts that are based on image processing. Then in the next session, we will use the OpenCV. We will run a simple example of OpenCV to load an image, then show that image using the image viewer feature of OpenCV, and we will save that image in a separate format. Then in the next session, we will manipulate the image based on its pixels, that is the finest element available for that image, that is a pixel. So we will do our pixel level manipulation in the next session, and in the coming session we will draw some shapes, some rectangles, circles, shapes like that we will try to draw on top of our image using OpenCV library. And then the next session we will proceed with transformations, image transformations like resizing, flipping, then changing the position, cropping, rotating, stuff like that we will deal in the next session. And then we will do some arithmetic operations in the image, and also we will do some bitwise based operations in the image. Then we have the masking of image. We will include a mask, which is our manually created image, on top of our natural normal image. Then we will perform some operations based on this masking, and then we will proceed with image channels. Basically, color image will be having 3 channels, then black and white images will be, or grayscale images will be having a single channel. So we will merge and split these channels from the given image so that we will have a better understanding about the image channels. Then we will deal with color spaces. The primary color spaces is RGB, and we will deal with few other kind of color spaces also, which is supported by OpenCV. And in the next session we will deal with histograms, which is a graphical representation of the intensity of light or pixels in that image. We will deal with histograms. We will learn how you can analyze a histogram to tell the nature of that image. Then we will make use of histogram equalization to equalize the image, to remove the rough edges of the image, to equalize the color, the contrast of the image using the histogram equalizer. Then we will proceed with effects like blurring. Then we will do thresholding, in which we will be converting the normal image into a binary format like either black or white, stuff like that we will be dealing in the thresholding session. And then we will proceed with gradient detection and edge detection, which is greatly in use in the image processing technology world. And we will be doing another exercise in edge detection using Canny Edge Detector. Then we will proceed with contours. Contours are lines drawn across the edge of an image, that is the outer edge of an image, which is also a very useful feature in detecting images inside a large image or a photograph. And then we will proceed with some artificial intelligence based applications like face detection, that is detecting the number of faces inside a large image. Then face recognition, in which the computer program will recognize the image based on the pre-learned faces. For example, a group photo of American senators, then the computer is pre-learned with Barack Obama's photo, then the computer will detect that particular photo, that particular face from that large photograph. We will be using a face recognition library called Face Recognition, which is based on Python. We will be using that so that we can quickly implement a face detection and face recognition program in Python. And in the next session, we will be using a technique called digital makeup, in which we will be loading an image and we will be getting the face encodings list, and we will modify those face encodings so that we can have the face look much prettier or maybe much scarier than before. And in the next session, we will deal with the face recognition magnitude, that is a face distance value. And in the next session, we will deal with real-time face recognition. So we are having an exercise where we process a live video from the camera of our computer and we will recognize a person in the video. Then later on we will go ahead with optical character recognition, which is also an artificial intelligence based application. Optical character recognition is an old technology actually. It has recently been improved. We will be using a library called Tesseract, which is also an OpenCV based library. We will be using that and perform optical character recognition quickly without having to deal with all the other complexities, since that library makes the optical character recognition very easily to do within your Python program. And the next session we will try to do real-time facial expression recognition using neural networks. We will be using Keras, TensorFlow and also the hair cascade classifier in order to detect the facial expressions. And then we will implement a simple real-time motion detection using our OpenCV library, and later we will try implementing object detection using pre-trained models. We will be using SSD, then we will be using Mask, RCNN and YOLO models in order to do the object detection. So overall, this is a complete package in which you can learn computer vision based technology, deep learning based face detection, then face recognition and optical character recognition. And by the end of this course, we will be providing you with a course completion certificate which you can keep with you and mention it in your portfolio so that you will be having more weightage when you are dealing with jobs based on computer vision technology. So without wasting much time, let's dive into this magical world. See you soon in the classroom. Have a great time. Bye bye.